All right, so we're going to start talking about optimization, which is an application of the first and second derivative tests for real life sort of things. Now, the first few examples we are going to use are going to be very mathy and not real applicable and more exciting to math teachers than to anybody else. But it's a good way just to start to see how the math of it works. A lot of the other problems you'll start to see how they could be applicable to engineering, especially engineering, but in reality, when you do engineering, you're going to need more variables. Usually there's more variables than just one or two, usually. And you'll have to know a little bit more about multivariable calculus, which you'll get to as you get into college next year. So we'll start by talking about an example. It's just easier to dive in, I think, on this more than anything. Find two numbers whose sum is 20 and whose product is as large as possible. Now, these steps below are similar to ones that are in your book. If you want to look at what your book does, that's fine. This is something that a science teacher, a colleague of mine, used to use to help her students organize her work. And it seemed to work pretty well for them. So we're going to talk about it. Information, find, formula, plug and chug units. IFPU, she called it. So start out with your problem and identify all the givens. And some of these will be a little overlapping. You've got to find two numbers. So actually I'm going to go down to my find and say, all right, I need to find two numbers. I'm going to call them X and I'm going to call them Y. You could call them whatever the heck you want. Whose sum is 20. Okay, so that's a given. I know that the sum is 20 of those two numbers. And whose product, okay, so I need to know the product, that's multiplying, is as large as possible. My washing machine is running in the background, so if you hear that funny noise, that's what it is. All right, so we have to make the product as large as possible, thus the maximization. We have to maximize. So write a formula that is to be maximized. Actually, we already did that. Dun, 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 dun. Determine a reasonable domain for the function. Well, they didn't tell us we couldn't have negative numbers or we couldn't have decimals, so all reals. What you're not really going to write that down so much as you're going to use a little number line to make a sign chart to help organize your work. And write any secondary formulas. Actually, we already did that right there. We have X plus Y equals 20. And then step 4 is to start using the equations that you have to solve the system and take derivatives to find extrema. Well, what derivatives do we need to find? We need to maximize product, so we need to take the derivative of product. We need to find P prime or dP dx or dy, depending on which variable you solve for. Now, I can go ahead and take the derivative right here, but then I have to take this derivative and I have to do a lot of substitution. I'll tell you right now, if you have two equations with two variables, solve for one and substitute in before you take derivatives, it just makes your life easier. You can certainly do it after you take derivatives, but it means you have to take two derivatives. It's just easier if you don't. All right, so I'm going to do this guy right here. I'm going to solve for y because I could solve for x. It doesn't matter. So my y is equal to 20 minus x. And I'm going to go ahead and substitute it into my product. So my product is going to look like x times y, which is 20 minus x. I'm going to substitute in. So my product is this guy. And I'm going to simplify. If you can simplify first, life is good. Now remember, the whole point is we need to maximize the product. So we need to take the derivative because the first derivative test helps us find extrema. So I get this for my derivative. Now, is there any place where my function has endpoints? Well, no, we already said it's all real numbers. It doesn't say we can't have negatives or anything like that. Where does the derivative equal 0? Well, if you solve that, that's where x equals 10. You'll have to do a little algebra. If you need to stop, you can. All right, so that's one critical number. And there's nowhere my p prime does not exist, so I think I'm good to go. I have one critical number at 10. So I'm going to check on this side of 10. I'm going to say 0 because it's easy. Let's see what my derivative's doing. If I put in 0, I get 20. So I have a positive number there for my derivative. And if I put something on this side, like say 11, I get 20 minus 22, which is negative, so I have a negative number here. So in other words, my P, my product, is increasing until I get to 10, and then decreasing thereafter. So I must have a max there, an absolute max there, as a matter of fact. And so my answer is that x, what these were x values, my x is 10, and my y is 10. So we have a max product, and I'm going to even add a little extra. They didn't ask for this, of 100, because 10 times 10 is 100. When the two numbers are both 10. Okay. So there's one example. We're going to do another in a second that maybe it will also be a little more mathy. And I want you to go and try a few to try your homework. And then when we come back tomorrow, we're going to do the popcorn project, and we'll see how we can maybe use it a little more in a useful manner.